Welcome to episode 24 of the Building Interactive website series, where we'll learn about JavaScript objects. Firstly, let's go over what an object is. So, an object in JavaScript is something that contains properties, and each property consists of a name or key to identify it and a value that's associated with the property. And it makes it useful for storing things with characteristics, such as cars or colors or anything else which has additional details about it. The first way that we can make an object is through an object literal. So let's say I wanted to make an object representing a car, which has make, model, and year properties. So I can create a new variable called my car, and I can use const here because I'm not going to be reassigning another car to this variable. The car is going to stay. The object itself is going to remain the same. And so then I can create my first property. So a property consists of a key and a value, as we discussed before. And so the first key is called make. And so I'm going to say Tesla for the make, and then the model will be Model Y, and then the year will be 2022. And so as you can see, we can go through all these properties one by one. So for the first property, the key is make, and then there's a colon, and then the value is a string Tesla, and then a comma to separate each of the properties from one another. And so then we have another property, model, with the value model Y, and then the final property is here with the value 2022. And so from there, we can log this new object that we created to the console. And as you can see, it shows us the details of the object. And we can also access these details making use of a dot after the name of the variable and then the key of the property that we want to access. So let's say I want to access the make of my car. And so you can see Tesla gets printed out. And then if we want to access the model, we can just say model here. So it's Model Y. And then year 2022. Additionally, you can also access properties by making use of square brackets and then in quotes the key name. So we can do the same thing, make, model, and then year. And then you can see it still works the same way. However, so the problem with just using these property names or keys is that they have to adhere to the same rules as naming variables. There can only be numbers, letters, or dollar signs, and it cannot start with a number. However, we can get around that by surrounding the name of the key with quotes. And this will also let us add spaces inside the key name. And so now you can see this key name is make of my car. And then you can see if we run the code, Tesla is printed out because that's what this key is representing. However, if we use quotes for the key name and the key name does not adhere to the rules of naming variables, then this means we cannot just use dot notation like this to access the property. And we need to make use of brackets with quotes in order to access it. However, if it does adhere to variable naming rules, then we don't need the quotes and we can just use this kind of code with no quotes surrounding the key. And then we can use this dot notation with the variable name at the front and the key at the end in order to access whatever detail about the car we want to access. However, let's say I don't want this Tesla Model Y to be the only car that I have. In order to be able to create more cars, we can make use of a constructor, which allows us to create multiple instances of an object. So in order to create a constructor for an object that's structured similarly to this car object right here, we can create a function. And then for the name, we can just call it car with a capital C. And if we were calling it something else, something more complex, like a food court, for example, then we would capitalize the first letter of every word. Unlike variable names or normal function names where we just keep the first letter lowercase, class names or constructors for objects usually have all the words capitalized. So that's why car also is a capital C. And then the parameters for creating a car object are the make, model, and year. And so from there, the way that we assign the make, model, and year to the car is by making use of this. And so this lets us access the car itself. And we can also assign it properties. So you could say this dot make is equal to make. It takes the make that's given and assigns it to the object. And then we can do the same thing for the model and also the year. And so instead of creating a new object now with an object literal, we can define a car like this with the new keyword and then the name of the constructor, which in this case is car. And then we can say Tesla Model Y and then 2022 for the make, model, and year respectively. And we can print all of its properties out. And as you can see, it works the exact same way as before. However, the advantage of using a constructor over an object literal is that we can create multiple cars. So if I were to say my second car, then we can do a Ford Model T from 1918, so it's a big year gap between these two cars. And we can print out the details of my second car too. And now you can see that we have two cars now, and both of their details are being printed out. And this is being made possible because of this car constructor, which lets us make multiple cars with multiple different property values, but the same names of the details, the same keys. And it allows us to create multiple instances of an object, like multiple cars, as you can see right here. And finally, details or properties of objects are not static, meaning we can change them, and we can change the value of a property of an object by referring to its key name and assigning it a new value using the equals sign, using the assignment operator. For example, for this Tesla Model Y from 2022, we can adjust its make by setting it equal to Ford instead of Tesla, and then we can change its model to Model T, and then its year to 1918. It's similar, it's the exact same as that second car from before. And so if we run the code, and we can also do a before and after here. So these first three values are before, and the second three show that this car's make, model, and year has actually changed. So by looking at this, it might be slightly confusing because the car was initially declared with the const keyword, which doesn't allow reassignment. But this is only if my car is reassigned directly. So if I were to reassign my car to a new car with Ford Model T in 1918, then it would cause an error because my car is directly being changed, while in this case, only the car's properties are being changed, but the car itself remains intact, which means that the actual car object in memory remains exactly the same. Its reference remains the same. It's just that its value has changed. And with const, with the const keyword, you can only change the car's value indirectly. You can't change what my car refers to, which is what this reassignment of my car was doing. It refers to a new car object that's been created, whereas this code is just changing its properties. It's not actually making a new car. This concludes episode 24 of the Building Interactive website series. Thank you very much for watching. Make sure to like and subscribe if you enjoyed, and make sure to look out for the next episode.